Hi class, we need to take a look at another type of inequalities. And in example 3, there's going to be two main types that show up. So whenever they mention an and statement, it represents, well, this is the symbol of the and statement, and it represents the intersection of technically two solutions. So you would have the solution of one inequality, which is this circle A, the solution of the second inequality, and n represents where both of them meet. If you have a statement that is given as an or, in this case, that represents the union. So any union, it's going to be given as an or. The proper symbol is the U, and union represents expressing the first set of solutions and adding the second set and expressing it as one. So any repeats, you remove them. And technically, this entire two circles represent your solution and no repeats. This portion here is the actual intersection. Okay, so let's take a look at problem 1. And here's the main process. You're going to solve both of the solutions and then check for the and or the ors. In this situation, this is an and. So it represents technically the intersection, which looks like a sad face here. And what we're going to do here is solve both of these inequalities. Notice that the first one is solved already, x greater than 5. And they want us to find the intersection with 2x plus 1 is greater than 21. So the first step is going to be to subtract 1. And this will give us 2x is greater than 20. And then we're going to be dividing by 2. And then we're looking at, well, x is greater than 10. Okay, from here, let me just express the solutions. So we actually ended up with x is greater than 5, intersecting x is greater than 10. Now, the problem's not asking, well, actually, it is asking for the graph of the solutions. So let me actually graph both of these. So x is greater than 5. It's going to have the following sketch. So this is technically 0, and I'm just going to put 5 here as a reference. Greater than 5, it's going to be all values to the right of it. So technically circle and every value towards the right. Notice that at some point, not to scale, we would actually reach 10. And then the second solution is x is greater than 10. And here is 0, this is 5, and this is 10. Now, the solution for the second one, it reads x is greater than 10. So technically from 10 all the way to the positive infinity. And then our main objective here is the following. Once you're looking at the both of the solutions, remember that the first one's already solved, so it's just x is greater than 5, not including 5, but to the right. And then the second one gave us x is greater than 10. You're going to look at the and statement, or in this case, the intersection. And the intersection represents where you have both of the solutions as 1. In this case, both of the solutions as 1, it's going to occur after the values of 10. Notice that the second one, x greater than 10 statement, doesn't have technically these values from of after 5 to after 10. You don't have these values, and I'm referring to these. And they start intersecting after the values of 10. So for example, 11, 12, or technically any decimal afterwards. So for the intersection, in this case, our main solution could be expressed as x is greater than 10. That is the solution to the intersection. It's just these values. And then your graph, you would basically say this is 0, that's 5, that's 10. And it's only going to include all the values after 10. So all of these we're supposed to simplify it as much as we can. And that's going to be the main solution, x greater than 10. That represents your intersection, or where both of the solutions meet. That's it for A. Now, notice that A and B, it's technically the same statement, except that this one is an or the union. Now, your union, it's going to basically be the following. We're putting both of these as 1 and no repeats. The values are repeating in the intersection. So if you had another one, let me just rewrite the whole thing so that it's kind of clear. So x is greater than 5. Once again, we technically have 0, that's 5. X is greater than 10. And I'm just going to put 10 as a reference. And x greater than 5, open circle, and to the right, open circle, and to the right. And in this case, if we were going to put both solutions as 1, the union would start here. So you have to include all the values of the first one plus all the values of the second one with no repeats. Notice that these are repeating. So we're not going to write twice from 10 to infinity. We just basically merge it as a single one. So in this situation, the solution it's going to be x is greater than 5. In its graph, I'm just going to put it again as a reference. That's 0, 5, and 10. It's going to start here. And this represents the actual union of both of the sets. Remember that, well, technically we're looking at ANDs, which is the intersection, ORs, which is the union. That's it for this one. So intersections, you're looking for solutions of the values that they have in common. Unions, you're looking for putting both solutions as 1. That's it for problem 1A and B. Let's move on to problem 2. And in problem 2, A and B, we have the same situation. One of them is an AND and the other one is an OR. Let me just check that they're the same. X minus 1 is greater than 5. We're good. X minus 1 greater than 2x plus 9. Okay, so let me actually start this problem by solving both of them. So the first one, we're just going to be adding 1, which is going to give us the solution to the first one. X is less than 6. Intersecting the second one, we're going to be adding 1. So we would have x less than 2x plus 10. And I'm going to subtract the x's and put them on the left. So minus 2x and minus 2x. So we're looking at still x is less than 6. Intersecting negative x is less than 10. And then we're going to be dividing by a negative 1. So remember that with the division, we flip the inequality. And we're looking at x is greater than negative 10. X is less than 6. Now from here, let me graph both of these. They only want the interval notation, but it's a lot easier to just basically graph them and then look at the sketches. So the first one, we end up with x is less than 6. So we're looking at this is 0. I'm just going to put 6 here as a reference and then its solution. So X is less than 6, open circle, and every value to the right. The second one is X is greater So the second one, X is greater than negative 10. And as a reference, I'm just going to put negative 10 here. And greater means, well, from negative 10 all the way to the positive infinity. Okay, at this point, let's actually look at the solution. Now, for the first statement that we're doing the intersection where these two overlap. And notice that they're overlapping here from negative 10 to 6. So it's just this region that they're overlapping. The first one doesn't have any values after 6 because this is less than 6 and not including 6. And the second one, no values to the left. So the values that they're overlapping are going to be expressed as, well, technically X is less than, and we're not including 6, and we're not including negative 10. So we're looking at X is in between negative 6 and 10. And I'm putting them as less than because technically it's not included here. It is here, but we're looking at which values don't match. So to the left of 6 and to the right of negative 10. They want the graph. So in this case, let me put the graph. So this is 0, 6, negative 10. And the solution for this one is the intersection of those two. So open circle on the edges. And we're looking at, that's our solution. The interval notation. So for the interval notation, we're just going to say from negative 10 to 6. Both of these are parentheses. And that's it. Our solution on this one, as we look at the intersection, is just the values from negative 10 to 6 positive, but you're not including any of these because of the less than statements. Once we technically look at both of those graphs, we can take a look at the union. So union means we're going to put this solution along with this solution together as one, no repeats. And notice that the only gaps that we have so far here is 6, but you're including 6 here, and then it goes all the way to the positive infinity. To the left, we don't have negative 10, but we do have negative 10 on the first one, and it goes all the way to the negative infinity. So the union of these two, it's going to represent all real numbers. So in this case, the solution would be all real numbers. The actual graph, I'm going to put 0, 6 here, negative 10, and since putting both of these together as one includes every value on the number line, we typically put the dot there and then the arrow to the right and the arrow to the left. Let me fix that arrow here. And in terms of the union, we're looking at all real numbers. So your graph is going to be, well, technically a little bit of a thicker line above it and arrows on both edges. The interval notation, it's going